I'm Shirin Abadi and I want to present my final project for the data center course. My project is bias detection system for presidential speeches. So the system consists of different components. There is a RESTful server that provides users with RESTful APIs to communicate with the system. There are worker services that consist of transformer and detector that they work together to evaluate and quantify the bias level. And there's also a comprehensive monitoring infrastructure to monitor the whole system. So this project, there are three main goals for this project. The first one is to create a scalable cloud-based microservices architecture for processing and analyzing the speeches. We followed the separation of the responsibilities paradigm to design the system so that we can scale, maintain, and debug the system easily. We ensure system reliability and performance by using monitoring tools like Prometheus, its visualization, Grafana, and also alert manager for automated alerting. And we also leverage existing NLP models and conversion APIs. So this system consists of several software components. We use Flask for the server, Docker for the containerization, Kubernetes for the orchestration, RabbitMQ for queuing the tasks and running so that we can able to process the requests in parallel, gRPC for intercontainer communication, SFTP server to transfer the file, Prometheus, Grafana, and Alert Manager for monitoring. Our Kubernetes cluster consists of 3 nodes with x86 64-bit architecture that has 2 CPUs, 4 GB memory, and also we use a standard network layer. So the system consists of a front server, a transformer, and bias detector. So prior to sending a request to the front server, client needs to upload their speech file to the SFTP server, and they need to send the path to the file to the front server. So by using process audio endpoint client can submit a new request to the front server. Then the front server will publish the URL of the file to the processing queue. There are multiple transformer workers that are consistently watching the processing queue, and whenever a new task is published, they will consume the task and they will download the file from the SFTP server. After they download the file, they will convert the audio file to the text file, and when the conversion is done, they will communicate with the bias detector using gRPC, and they will send the text to the detector. The detector will apply the NLP model that we talked, which model that we are used in the report. It will apply the model to the text file and it will compute the bias score. And it will send the result back to the transformer. The transformer will publish the result to the results queue. And actually, front server consists of 2 threads. So the first thread runs the Flask server, and the other thread is consistently watching the results queue, and whenever a new result is published, it will read it from the queue and it will store it into a global data structure. So when the client sends request to get result to query the result for a specific audio file, the front server will read the result from that global data structure and it will send back the result to the client. So for testing, first of all, I set up an SFTP server in Cloud Lab and I uploaded a test file into it. Then I tested the functionality of the system to make sure that it's functioning correct. And also I tested the monitoring system. Here I want to give you a brief demo. First of all, I want to show you the SFTP server that I already talked. So this is the IP of the SFTP server. As I said, it's in the Cloud Lab. And here you can see that I have already uploaded a test file into it. Next, I want to show you the infrastructure for testing that I'm using. I created my cluster in the Kubernetes, which consists of 3 nodes. They are E2 medium nodes. And here you can see the different pods that I've deployed, bias worker, front end, and transformer. And I also deployed RabbitMQ, and here are the services. So for example, front end exposes a external IP so that clients like me, we can communicate and send our requests to the server using this IP. And bias worker is the gRPC service, and also RabbitMQ is the service for the RabbitMQ. So here, as I talked before, there are actually two APIs. The first one is the process audio API that you can see here. It gets the path to the audio file, and when I send it, it will tell me the status, which is queue. Then the system will process this audio file. The next API, the endpoint that the system provides is the get result. Get results also gets the file that we want to see the result for it. So when I send it, it will send back the score that the system have already computed for this. And I also want to show you the graph on a dashboard that I have. I'm monitoring CPU usage, memory usage, pod status, and container restarts for different containers and components that I have. The other one is that I have configured my primitives to send the alert to this alert channels that I've created in the Slack. So when a threshold is passed, for example, 500 megabytes for the memory usage, it will send an alert to this channel in Slack. And also for debugging, I used logging in all the services and components that I have so that I can figure out where there is echoing and what's the error. I use kubectl tools like describe or get-oy to see where in the deployment I'm getting the error. This system has a couple of bottlenecks. The first one is that, as you saw, the nodes that I'm using have low memory and CPU, so that we need to scale them up and we need to use better nodes. If the audio files are very large, it will consume a very high network bandwidth, especially by the transformer when it wants to download the file from the SFTP. So it's good to pre-process the files before uploading them to the SFTP storage. And also single frontend can be a single point of failure. So it will be good if we use load balancer and we have distributed servers. Thank you for your time, and you can send your questions to this address.